네. Hello, good morning, everybody. Hello, I hope I am audible.
Yes. Yeah.
Yeah, okay, thank you. Yeah, so welcome to the course of EEX3417 Software Development for Engineers. So today we are starting our first day school. Uh, Actually, I am Gyan Anthony's, the one of the academic coordinator, uh, and also uh, the another academic coordinator, Mr. Neil Herath, also available with us during this session. And other two coordinators are Professor Udita Ratnayaka. I think she is not in this today's session, and Mr. Nilanga Vitanage. So, as you know, this course is compulsory for all the uh, specialization in the Faculty of Engineering Technology. So you can find the course through your ULMS with respect to the EEX3417 web page. So next, I just need to give some very quick, just some guidelines about this session. Okay, as you already know, since you may know now, I think all of you have done the faculty common two courses, that is EFIL and the EGAP by the now. And so the all the day school are conducted via Zoom platform. And the other thing that, as you know, this is the EEX3417. The E is the first two digits are denoted for the electrical and computer department, EE, and the X is denoted for the category engineering. And there are other categories, as you may know by now, Z categories, which is relevant to the maths courses, and the Y category relevant to the project. And there are M category relevant to the management courses, like that. And the first number, uh, that is the fourth digit of the course code. First number, which is here, is 3. It denotes the level of the course, which is level 3 here. And the second digit, the second number, the 4, which is relevant to the credit level of this course. So this is a 4 credit course. And why we need this credit level, actually, because in order to satisfy uh, your time period that you spend to in the each course, it depend on this credit as well. Because in generally, for the one credit course, you have to be spent at least 50 hours. So therefore, this is 404 credit. So you need to at least 200 notional hours uh, spending for this course for DBS successfully pass. Uh, and it include actually do the assignments and do the labs and do participate the midterm exams. The midterm exams normally we are calling CAT, continuous assessment test, and the final project, final mini project, like that. So all the activities for the all the activities you need at least 200 hours, notional hours for this course. And here there are some I mentioned the less guideline. So change your name, your actual name, and then we know you have participated during this session. And please mute your microphones unless you need to ask a very technical question during this session. And raise your hand, and don't time to time raise your hand. I will give some time to raise your hand to the questions regarding with some minimum time. Okay, so now let's see what is inside this slideshow. So here the course information. As I said earlier, this course is compulsory for uh, uh, all the department in order to get to a degree. So and normally this course is covers. You may be you will know this. What are these symptoms and what are these definitions later when you are doing this course. Actually, it is the basics of some flow chart, algorithms, flowchart algorithms, programming language. So one of the programming language we are doing. So we will focus mainly the C language to do your assessment and the lab works and the mini project. So, and on the other hand, there are some software engineering concept. There are large number of software engineering concept, but here we are normally focusing some basic software engineering concept in order to success your activities. And there are some relational database, we call the database handling part in here. That is we call the relational database concept. So the next is the important factor, assessment. There are actually 7 assessment in this course. There are 3 labs. 3 labs, 1 TMA. TMA means tutor mark assignment. That means you have to be work on the that assignment and submit the result. And there are 2 CATs. 2 CATs mean, as I said earlier, the CAT mean the continuous assessment tests, which are in generally we can call them midterm exams. Midterm exams are there are 2 midterm exams, and the finally before the during the assessment period, mini project. So this is the other important factor. OCAM. The OCAM mean what is the mark you will get in order to get the eligibility for the final exam. So what we are doing, as I said earlier, there are 2 CATs. We will get the best CAT. Out of the 2 CATs, we will get the best CAT marks and multiple by 0.2. Here you can see it is in 0.2. And then we get the average of the lab 1, lab 2, lab 3. So therefore, all the lab 3 are compulsory. If you miss one lab, you will get 0 marks for that particular lab. And also remember, the scheduled lab are fixed. We will unable to extend the further labs if you miss this. So therefore, please participate your corresponding selected lab to get the success. And from the after taking the average lab, we will multiply by this 0.3, and then there is only TMA1. So TMA1 will get only 0.01 because it is some open assessment. No? So therefore, we are given only a small amount of marks for TMA. And finally, the mini project. The mini project is actually the highest marks you will get with ratio 0.4. So after adding all these marks, you will get the OCAM marks. So the eligible criteria is you need to satisfy both these 2. Remember, not only the OCAM, not only the minimum mark for 40 marks of the OCAM plus the mini project. So here it is and. So that means that both these 2 criteria should be satisfied. So as an example, let's see if you have a OCAM max 55 or 50, something like that, but you have not submitted the mini project. So that means you will get 0 marks. So then you are not eligible to sit for the final exam at the end of the academic year. So both should be satisfied. And as usual, the final exam is you have to be passed at least for the 40 marks and to success your course grading. I think this slide you may now understand. So, so actually what we give to you and what you learn from this course at the end of the academic year. So, you should be able to do some demonstrate or some ability to the requirements of the developments of the, so that means that if we if the person or if the company need some software solution, software system to their requirement, so they should be able to uh, handle how their requirements will be gathered by yourself to develop the basic software solution. We are not talk about hard, complex software systems during this course. It's very extremely very basic software because as you know, this course is doing the other other. I mean, all the specialization, civil, mechanical. Electronics, electronics, computer, trickle, all and other thing, all the things are, all the department specialization are done. So therefore, we are not given too much complex system for to analysis purpose. And the second is you need to be find some problem solution to the proper algorithmic. The algorithmic solution means the step-by-step process. And in order to describe the step-by-step process or the algorithmic solution mean, there are some several number of techniques. Either you can use the pseudocode technique. So we will explain what are the pseudocode algorithm and generally the flowchart. The flowchart is actually the graphical representation of the steps. Whatever the step, that particular algorithm, we can show to the user or show to the person in graphical way. They are standard in the flowchart platform. And the pseudocode mean it is we are simply represent the English terms with the English statement. So we will see in later slides. And the other thing is the problem you have to be structured. The design principle. So design principle means in software, when you are design whatever, it is not relevant to the software system design, whatever civil or mechanical way, anything. If you need to design, so you have to be structured or you have to be organized very properly. Their principles. So in here, we are normally using some basic design principles in the software design available. And yeah. Hello, please mute your mic. Please mute your mic, don't disturb it. So, and the structural design principle. And the other important thing is there's a concept called in software systems, the object-oriented design principle. So this is the basic principle, and this will use highly in the advanced courses if you are selecting, if you are in the computer engineering specialization or the Bachelor of Software, Bachelor of Engineer, Bachelor of Science Engineering Computer Specialization. So these things are actually we are focusing only the basic design principle in order to get your idea about how the problem can be solved by using these techniques. Anything, yeah. So then the next bullet. So we will apply the fundamental concept of programming. The programming means, as you already know, you may know, the whatever we are designing a system, we need to program. Program it means some specific language. So here we are using actually the C language. The C language is actually the very powerful tool to write everything, mostly in everything around the world. So therefore, we will focus the fundamental concept to write that particular system in C language and how we test. The test means whether it gives the proper result what we expect. That is the testing mean. The debug mean we will check one by one at a time, one by one, whether it gives the correct answer or correct result we expected. And finally, the deploy the computer program. So that means how we can finalize all the system that the corresponding system that we given. Another thing that the database management. So generally we call it DBMS. You can see DBMS, which is the database management system. As an example, as you know, the university in our university, all your records, your name, registration number, what result got the ALL and the oral, and the what result after you pass in the academic year, like that. So all these things are your data. We need to be stored there somewhere. So it is we call how your database, your records will store in the database, and the management we call it as a management system. So therefore, this kind of techniques or the system we will focus very briefly, and not too much for this course because this is a level 3 course, and all the other specialization are participating. Therefore, we will give only the basic representation of the data. But you will, if you interest, you can do in later in the other courses in the computer specialization subjects. Anyway, okay, and not only that, this is actually this one is the most important one nowadays because of the security threats. The software, as you may have heard, some cybersecurity warning and alert. So these things are in very extremely high nowadays than the last few decades. So we will check. So we will give some idea about what are the security threats for the software development systems can be handled. And finally, at this session, at this course schedule, the numerical computing software. So you may know, especially the engineering, when you need to solve the engineering problem, you cannot do in simple for the calculation by our physical calculator. So it is little bit hard, not a little bit hard. It is hard to do the because most of the calculators and some scientific calculators can be only using the mathematical basic operation plus minus like that, and on the other hand some matrix calculation like that. But there are some specific computer tools for that purpose, especially the engineering relevant programs. So therefore, we will give some basic idea about the numerical computing software as well. So as I said earlier, there are 3 lab sessions. All the lab are compulsory because it will give some portion to the average portion of to the your eligibility criteria marks. So your continuous assessment mark, we will get all these 3 labs. So during the first lab, so you can get the better idea when you are participating for the lab. I just go through the what is actually doing inside during these 3 labs. The first lab is basically we will focus how to design an algorithm, the flow chart, which I mentioned. The flow chart is the representation of the algorithm by graphically. That is easy. Then, as you may know, the graphical representation is understandable more than the written representation. So that is why you need to know about how to draw a flow chart for specific algorithm or whatever design. And we are considering the C, as I said earlier, C programming language. And here at that time in the during the lab 1, so we will find the standard coding techniques, because it is not proper way to write all the codes whatever in this format. There are some standard technique to how to write the code, whatever like that. So we will learn those things in that first lab, and it is actually the executive. Executive means run the program. The debug mean, as I said earlier, you need to check the errors, what is happening there, like that. And the second lab will focus on the database handling system, as I said earlier, DBMS. We call it the database management system, DBMS. And the third lab, we will use some simulation software with some specific basic problem, not the hard problem, to a simple problem, by using some simulation software with the concept of the lab 1 and lab 2. And sometimes there is a part of the TMA1 also will be used in the third lab. So then you can get the practice activity from your TMA1 for some part. Okay, and specifically in the mini project, we are you have to be focused on three major contribution. So find the client. The client means the customers. So sometimes the mini project will give the notable example for the template for that for the client. And then you need to gather the requirements. So gather the requirements mean you need to get their requirement, what the customer actually need, what kind of software, what kind of system they need to do with you. That is we call the gather requirements. And the second is analyze requirements. Analyze requirements. After you getting the requirement from that customer or the client, then you need to be analyzed in separate way. So you will be focused in that during this course in the later day schools. And also please check your course material as well. So this is actually we are expecting the result. How you design that particular requirement in software manner, and designs, and then the implement. How you implement? That means how you given the solution for that particular example or particular problem to that customer or the client. And not only that, because if you do the wrong way, because sometimes the customer asks something else, but you are doing something else, so then it is not a correct way. So therefore, you need to be test the result of the implementation before handing over to the customer or the client. So therefore, we will teach you some kind of testing, and we are expecting from your mini project these three specially and these two. So this is we normally call the total solution of your mini project. And remember this as well, don't copy in each other. You will get the minus mark and also maybe 0 marks. If you copy 100%, definitely you will get the 0 marks from each of you, whoever copy. And if, as I said earlier, if you get the 0 marks for the mini project, you will not eligible to sit for the final exam, even you have the 60 marks for the other activities. Because the mini project marks and the other continuing assessment marks are need to get the eligibility of for the final exams. So don't try to copy. If you copy, you will get 0 marks for the mini project or the negative marks reasonable amount. Because the last time we did not consider this too much, but now we are considering this much, because the last time we found that there are some direct copies from each other. So at this time we will very strict on that particular incidents. Okay, so you can refer in addition to these books, these online links, in addition to your course material. So you can access this MySQL tutorial, which is relevant to the database management system which is doing in the second lab for this course. So you can access these things and books. And there are so many books in the library, especially Colombo and the other regional centers as well. And also there are so many resources in internet. So many resources in the internet, so you can access, you can find out. And if you not uh, cannot find, please come and see with the Colombo Regional Center. Okay, so are there any questions regarding the above, which I mentioned here? But very few minutes, only a couple of minutes if you have a question. Otherwise, I will continue, and later I will give a chance to ask questions.
Excuse me, sir.
Yeah, okay.
Do we have lab sessions in BRC, sir?
Hello, I cannot hear. What is?
Do we have lab sessions in particular regional center?
Yeah. All the labs, most of the lab sessions are, all the three lab sessions are in particular center Candy. And I think you will inform within next week in the LMS what are the lab sessions in the each center. Mr. Neil, I think.
Yes, you can hear
Yeah,
me, no? Yes,
yeah.
there will be lab sessions in particular center. I already included in chat area what centers uh, we will conduct lab sessions.
Yeah. Okay. Yeah. Okay. Thank you. Other questions? If it is not there, then I will start. Yeah. Okay. So I will start the session again. The corresponding relevant stations now. Don't disturbing. After the session 1 and 2, I will again give some time to ask the questions. So don't disturb again. Please mute your mics. Okay. So why we actually need the software systems for engineers? Not only the computer engineers, other engineers as well. Mechanical, civil, electronics, electrical, mechatronics, uh, bioengineering maybe. So why we need it is important, the software system for engineers. Actually, the software now it is very extremely uh, far away, and the software tools are used in almost every area. So, but sometimes you may be not thinking whether those software systems have been used in that particular uh, area. No, it has use, but you didn't, or you don't know what is inside that particular platform. So other thing that so when you are as an engineer. Remember, as an engineer mean not only the computer engineer, all the engineering platforms, not only the computer or the electrical engineer, but whoever the engineer, you may need, actually not you may, you should need to work out these kind of developments. So you may need to actually do some simple programs. If check your description or the whatever you need to do, you may need some your own simple programs, either in the academic when you are doing your degree, or after your degree when you are doing your career. That's mean your job. And the other thing that you may need some making the decisions in this to whether to buy or develop the software in house. So what kind of software you may need during your academic or during after your degree as well. And there are some automated systems in your workplace, because the most of the time now, all the workplaces, I think more than 99% or maybe 100%, all the workplace are use some systems, especially for the automated system in engineering field. So without the automating system, they cannot actually survive, because while we developing the technology, if we can able to do the complex systems in future. So therefore, almost every engineer sector, engineer workplace, there should be a system with at least a partially automated system in their workplace. So those things, because of those things, you need to know about some software systems or somehow. But if you are doing specifically the computer engineering, you definitely have to know more than 100% success of the software systems. If you are doing the other degrees, other specialization, you may know some certain part, not but you should know at least for some systems development during this degree. Okay, here are some actually almost every engineering specialization, it role a major role in the computer system, civil. When you are, as you will know, when you are doing your civil specialization, when you are drawing, or before you construct or before you implement the large complex system, you need to be actually first to try out by using the drawing or the some model. So that model we are preparing normally by using the software tool, because when you construct the bridge, so you have to be consider what kind of strength should be and what kind of shape and what are the materials. So those things may be you can think in your analysis, but you will get you will need idea about what kind of properties it may be very successful in order to build or construct the bridge before the actual situation. So that is in nowadays there are not nowadays in more than 3-4 decades there were some civil construction software simulations in the field. And other thing that the textile engineering, before you prepare the textile cloth or whatever, the shirt or t-shirt or sari or whatever, you need after you prepare that kind of clothes, because when you are doing the massive manufacturing system, you cannot prepare all 1,000 or 10,000 amounts of that textiles if it is wrong. So therefore, before that, the manufacturer need to test whether it is the capability of the customer's requirement, or it may be the color. Also those things you can handle actually by the simulation software in the textile engineering. And for the textile when you are doing after you get in the textile degree, so you may be better, because most of the in the country and almost the outside the country, that means internationally, all they are using the textile concept, the software simulation to proper manufacturing process. And another is the electronics. As usual, as you know, the electronics and the communication engineering, they need the proper software design, especially as an example for the smartphone and the laptops, whatever. Because in near future, the pure electronics may be vanish actually. The pure electronics may be vanish. All are, I mean, the physical components may be definitely it may be exists, but the idea about this concept of the pure electronics, how they work, may not be need to, because of this computer systems, which is almost controlled by the using the software systems. And the other thing is the electrical as well, because electrical also now we are writing the simulation and work out what will happen when we are doing this kind of things in the actual before the implementation. And another is the mechatronics. The mechatronics also you may because nowadays almost the mechanical part But earlier, is most earlier, maybe before 40 years ago, the mechanical device was mostly controlled by the mechanical uh, parts as a mechanically. But now it is, they embedded actually the electronics, actually the mechatronics mean actually the mechanical plus electronics plus maybe they embedded the software. So nowadays, the mechatronics engineering is actually based on the software plus tronics and the mechanical as well. And the other things that the mechanical engineering, how we can construct the vehicle without uh, in good way with the normal smooth constructions of the road and whatever. So therefore, this uh, I mentioned only the six engineering fields, but there are some other engineering fields. Most of the engineering fields are use this computer software because nowadays are the extremely powerful the computers than the rather than the 20, 30 years ago. Now extremely powerful computers uh, are available in the market. So therefore, they are trying to do whatever uh, which was not done in the previous. Okay. So just now I will just go through this some category or some components in the software system. So there are some according to the according to your course, we will some we can actually it is not the categorization. It is we can give some idea about some specific terms. So computer programs, configuration software, and the documentation regarding. So the computer program in actually the set of instructions that tells the computer hardware. As you already know, there are more components inside the computer, either laptop or desktop. So those are hardwares. Then how we communicate the interconnection between the hardwares. So those things we need the definitely some communication link, which is we are use the computer programs. And the configuration software mean but you may know from the single computer program you cannot specify or cannot do the specific task by itself. So you need to be use some configuration from that software to that much, that software to that part, like that. We have to be configured. So in that case, we are calling the configuration of the software for some specific task. And other things that the system documentation and the user documentation. The system documentation mean actually when you are, but nowadays it is available in the some online as well. When you buy a software, it will give the what kind of how to install that software in the computer or the laptop, and how that product is communicated. Those things are is a part of the system documentation. And not only that, this is the how the user need to how the user can apply and see that product being used. So that is actually the user documentation. So nowadays these things are mostly available in the website. So early days, the product manufacturing, they given the CD or whatever information that include the needs. But nowadays you can see it is in the website. Okay, so this is important. No? As I said earlier, the computers, sorry, LEDs, laptop and the computers, whatever, the desktop or there are, as you know, the hardware devices. There are hardware components, but with only the hardware devices, the computer cannot control. The computer actually it is unable to do anything. Only if the hardware is devices. So we need to active those hardware devices. So that is, in order to do that, we are using actually system software. The whatever the software we need to do, we need to embed it in order to get the better performance from those other. Because if it is only the hardware components, you cannot control anything. So therefore, we need to communicate with those hardware components that we call the system software. And remember, the system software is not only the single term. There are some couple of software types. So generally, first thing is the operating system. And the other thing is the utility softwares. Actually, it is a utility softwares. It is plural, utility software. So then how we can communicate the system software through the devices. So in that case, we need to some connection. So those connection actually is doing by the drivers. The device drivers is actually the software type. This is not the physically component. This is a software type device. How this device, the hardware device, can be communicated through the system software. So in order to do that, we are using drivers. We call it drivers. How the devices are communicate each other, whatever requirement of the user or the customer. So we are using the drivers. So mainly the operating system has the capability to handle all of these drivers, mainly. But there are some additional things. So the operating system is actually the relevant, actually it is something like called most of the 90% or something to communicate the hardware, the operating system. The utility softwares mean actually the whatever we need, our requirement. So we will use the so many utility softwares. There are so many around the market. It is depend on the whatever our requirement. And as I said earlier, the device drivers. And not only that, after the system software platform, we need the user is here. That means ourselves. But we cannot access directly the system software. So we need some applications in order to successfully resolve for our requirement. So we use the application software. So that is the application software. Here also there are multiple application software. Okay. So this is the generally the software classification we will focus during this course. So application software, operating system, utility softwares, and the device drivers. So here I have given some examples in order to get the idea about those software types. In the general purpose softwares, as you know, the Microsoft Office, we are normally using, if we need to write the document or whatever report, so normally we are using the Word, and also some spreadsheets calculation, you can use the Excel, and some database, and then you can use the Microsoft Access for some specific part. But there are, other than that, there are a large amount of general use purposes. But in this exam, in this slide, I have shown only the couple of few application softwares. And there are some project managed softwares in because most of the time when you are go to your job, or when you after the degree or what, or sometimes you may already know the most of the companies, the large companies, they are using some management softwares in order to success for their project. Because this is very important things. And so those are some general purpose. And there are some application software here, which is based on the to run on the actually the operating system, because as I said earlier, without the operating system, you cannot communicate anything from to each hardware components. Without the operating system, you cannot actually you cannot identify, even the computer cannot identify the hardware also without the operating system for somehow. And there are some also some user programs, which is the application software. And there are some specific platform, specific software application to do some specific systems area. As an example, for the numerical calculations. For the numerical calculations, the software such as MATLAB. The MATLAB is the most engineering tool that we normally use, the engineers and the scientists, for analyzing the engineering system. As an example, for the satellite communication and the aerospace engineering, mechanical, the large mechanical machines. So all of these are analyzed through the MATLAB, and there's another one called inside the MATLAB Simulink. So those things are very extremely powerful when you are doing the engineering systems, because if the company or whoever try to build directly the implementation, then they may be failed because you can see, you can understand it is actually money. The money will waste when if you not the proper analysis of that particular engineering system, you will waste the money, so many money, large money. So therefore, in order to reduce that kind of problem, generally by using the MATLAB or the Simulink, they will use the software in order to success their final implementation. So that is the one thing. And the other thing that when doing some drawing drawing, maybe civil engineering drawing, no mechanical drawing, no, mostly we are using the AutoCAD software tool. So all of these are actually is a part of the application software, all the things. Software, what we need in maybe in next after 10, 20 years, these may be our day-to-day life requirements. Okay, so the other called the system software, which is based on focus on the operating system. As you know, there's in order to active the laptop or whatever the device, there should be operating system. How the system can operate, that we call the operating system. So generally, you will be friendly with the Microsoft Windows. This is this one, but it is not the only we have the Microsoft Windows. So we have the other the Linux. The one of the other Linux platform is called Ubuntu, and the Macintosh, Apple Macintosh. So those things are some other type of operating system available at the market here in the general market. And not only that, the device drivers, as I said earlier, how the drivers, because without the drivers, without the device drivers, you cannot, the computer cannot handle, and the computer cannot control the devices which is plugged into that laptop. As an example, I am using the mouse with this laptop because I am using the external mouse for the laptop. If there is no device drivers relevant to the mouse, then actually I cannot even move this key, the mouse movement. So therefore, the drivers are important. So that is the part of actually the system software as well. And the other things that the programming language, which is actually we can whatever we need to do. So we need to install some programming language as C compiler. There is a Python, mostly famous programming language nowadays, but it is actually depend on time to time. So sometimes in the early days, C compiler is more powerful compiler, but most of the time, nowadays, whatever the software packages are based on actually this C compile, and some this is a Python interpreter, and also some the firmware being to communicate the microprocessor and the other hardware platform to the computer. We use some firmware software. So this is the system software packages and some example relevant to the this course. Yeah. So, and there's as you know now, since most of these are market tools, so therefore there is some license and the copyright issues. So you can, if you find some document or whatever the relevant with this kind of open source contribution, so that means it is freely available for anyone. If it's a closed source, it is not available. You have to be purchased, paying some money. And the copyright is normally given to the creator of the work that actually it is given, whether it is a software package, so we are call it as a creator. But if we, as an example, if it's a document-wise platform, that means the papers, research papers or journal papers, so that is we are calling the authors, general term for the author. And therefore you cannot use directly without get the permission from that creators or the authors for that particular platforms. So if there is some C mark with this kind of symbol, so it is with the copyright mark. And there are some marks with R. And this also is something like copyright, but it is actually the reserved for this particular author. So just go through this kind of symbol. You may be useful when you are doing your further software-based platform in future. Okay, so this is some general things. These are some because the trade secret mean it is the fully business platform, because their information maintained as a secret. They will not share the trade information, and also some security purpose of the especially the military services. They will not given the information whatever in the website. And proprietary mean that means the who the publisher and who the developers are, because the develop as an example, you can develop, but you may not able to publish because since you may not have the money or whatever the rules and regulations concerned. So you need to be find some publisher. So that is why it is exclusively property of their developers, or the publishers may be need. And the other thing that if it is there's a freeware, mean you can use the free of charge without the source code. The shareware and the premium mean you have to be paid for the additional features for in that particular software. And if there's a complete Fox fin, so that means you have to be full open source software. In something like that, so you can use so that software is a full open sources, and there is a source code on the common maybe website or wherever you can access commonly. And if it is a public domain, that means there are no ownership. Everybody can access that particular software free of charge. So this is just I give us some idea about the licensing and the copyright concept in software. So now let's see some another couple of slides, some important slide about in the theories behind in this course, this according to this first day school. So some computer program, basic one, and how the programming history is success to up to now, and the features some high-level languages and the program. Let's see some couple of things. So if you remember, I mentioned earlier, the computer program is a collection of instructions. How to do, how it can be do. So that is actually the it is in so we are written in some simple English or some simple maybe the English means since we are talk about English, but maybe as an example in China they are writing their programs in Chinese language, but it doesn't matter. So anyway, so it is actually the collection of the instruction, set of collections of the instructions is actually according to that specific program we need to write. Their standard way. Otherwise, it will give the errors. So those is actually that is a computer program. And the other important thing is that so we need to give the instructions in proper way. That means the in the program way, as I said earlier, the instruction should be because we cannot give the instruction whatever we like. No, you cannot. If you use the C language, you need to give the instruction according to the C standard that we normally call syntax. And if you use another language, as an example, Java language, you need to give the instruction according to that standard, or we can call the Java syntax property. So like that, if you use other language, you need to give the relevant standard method, way or the instruction in order to get the success of the result of your program. So and also, so here the so after we given that program, the program translated from the human. Actually, we are given from the English language, no? So English language everybody can understand. So then that will be converted to the computer readable format. So that is actually via the computer readable format mean we are calling it machine language. The machine language is actually zeros and ones. Or some we can denote it as a true, maybe true and not the true. You can change it as a binary language because the if someone asks what is the minimum of the alphabet in around the world, the less number of alphabet characters have which language? Actually, it is a machine language because it has only ones and zeros, either top value or the bottom. So anyway, so you will get an idea when you are doing this kind of programs. And the other thing that in every program, performing the three basic tasks, that means whatever program or whatever system, as you know, this is not relevant to the software platform. Whatever process you are doing, either it is mechanical or whatever, anything, or our day-to-day language, our day-to-day application as well. Yeah, so if you need to do the process, you need to put the input. And after doing the process, it will give the output. So that is the basic general common thing, not relevant to only for the software. The manipulate the data, that means you need to give the proper data, and the perform the operation mean it is do the process. As an example here, I need to add some two values, A and B. The whatever assigned for the A, something we can give here A is 3 here, and B is 2. So these are my output, input. A is 3 and B is 2. And the process is get the summation of these two. So it is a 3 plus 2. Then the output is actually, according to this example, is 5. So that is provide the result. So whatever the system, not only the computer system or the system platform, whatever in day-to-day life, we have a process, we given the input, and it gives the result, which is the output. So this is the common way we are carried out during our day-to-day life. So here it is in the platform to the software platform, software language platform. Okay, so here the history of program language. So there are some in early days, the computer program actually written only to the, because as I said earlier, we can understand the English language, but the computer cannot understand. The computer can only understand the machine language, which is, I mentioned earlier, only zeros and one. Only these characters can be understand by the computer throughout the starting from earlier. So therefore, we are writing in English. We are writing in English, but machine can only understand the machine language, or we can say it is a 0, 1, or the binary 0, 1, or the machine language. This is machine language. Machine language, not the machine learning, machine language. Or sometimes we call the binary language as well. So we writing in English, and the machine can understand on the machine language. So we need actually some kind of translator. How it can be converted to this machine understandable language. So in that case, we are generally using this kind of categorization. Actually, the English, we are writing in English language. According to this course, we are using the C language. There are so many languages, C. So actually, the C is a high-level language. These are high-level language. The machine language, which I mentioned, it is only the zeros and one. That is actually the machine language. And there are some assembly language. Actually, the assembly language is relevant to this translation. As there are assembly language, which is actually relevant to the translation of this, because the user can understand this language. Here we are using in English, which is mentioned about the C language, is called the high-level language, and it convert to the machine language, which is the zeros and one, by using some assembly language. And there are some inside this process, there are some large number of steps. It is not directly converting these things. So you will find if you are doing the specialization and computer specialization in your high-level course. But at the moment, we are not teaching you these things, because this is highly relevant to the computer engineering specialization. So here is some machine language. As I said earlier, the information represent can only ones and zeros, and denoted we normally is on state and the off state in electrical. So that means if the power is on, we are the power, the ampere current is 1, we are putting is 1, otherwise 0. So likewise, this is the same thing is the relevant to the electrical or the electronics platform, 1, 0, like that. So, and the machine, actually we cannot understand the machine code too much. Only maybe few number of codes maybe understand, but the machine, general user cannot understand the machine code. Yeah. So as an example, you cannot understand these things if it is not this here. So these are we call normally comments. These are we call the comments. What is actually doing from that particular instruction here. So CD80 is so relevant to some, it mentioned as a Linux system code. And as an example, the another one is this B810 6F. So like this is relevant to this moving the oral ID into the EX. Actually, EX means some registers which relevant to the architecture in the computer. So actually, we cannot actually understand the machine language. The people cannot understand the machine language. The computer can only understand 1, 0. So actually, this is the assembly language. So this assembly language is using in order to translate our English code, just normal high-level language codes into the machine code. So because, as I said earlier, the computer cannot understand the other languages. It can only understand from the binary code, which is the machine language 1 and 0. So in order to do that, definitely the old software turned into the machine code before sending to the CPU. The CPU means the central processing unit. That means the main processor of the computer, either desktop or whatever, laptop, anything of tab or what thing. It is need to convert to the machine code. So here is the another assembly language platform. So you can see, as I said earlier, there are 1s and 0s, but here it is some little bit understandable language as well. This according to this program, it is add CMP means compare, and MUL is relevant to the multiply, and likewise, so you can here it is integer value, some calling this kernel relevant to this address. We are generally called so you will find some more detail when you are doing labs second lab. So, but during this course, it is no need to be too much. You have to be focused these things, especially the non-computer specialization. But for the computer specialization, you will be focused on next high-level languages, these kind of things in the high-level languages, especially microprocessor, computer architecture, processor design, comparison. So for the computer specialization students will more understand these things in later. But at the moment, you have for all the students need to be just got the touch idea about what is going in here. And here is a high level language. So we are writing from this. Here it is the, as an example, here it is a C language. So this is the C language. So here we are writing this way, because if we need to write the C language, we have to be writing this standard way. Otherwise, it will give the error. So these things we are calling in preprocessor. I remember in next day school, we will focus mostly on the C language day school. So in the next from the I think tomorrow day school, it will be focused fully on the C language basic programming concept. So here just I go through the what is actually doing here. So this is something like we call the standard input with the header file. H mean header file. Dot H mean header file. Because if you not put this thing, if you not put this thing, this word printf, this command cannot understand from that C language. So therefore, we call this is pre-designer. That means in order to understand this command from the C language, you need to put this, we are calling this as include the standard std for standard IO mean input output. So actually something like this. So you have the C language. There are so many, let's see some bags, but close the bag. Let's see, there are some bags, but all are closed. with some notch with the. So you need to open that particular black. So that is something like that. We are putting the include that standard header file. We call it, this is header file. But some so int main. So those things are standard thing. So the C language it understand because these things are is inside the C language, and they have not specifically put into some bags. So this is already know by the C language, but there's some specific keywords. So we are calling these is keywords. Return is a keyword. Printf, because the keywords mean you cannot use this keyword to any purpose other than the original standard one. You cannot use these original keywords. You cannot use this keyword to a purpose, to a private. As an example, you cannot use this RETURN return keyword as the variable. So you will teach. So we will teach in tomorrow some C programs. So you will get a better idea about these things. Anyway, so this is starting from the main program, and this curly bracket open and the curly bracket close mean that is we are mentioned the we are ordered to the C programming start from this and end from this one, and inside those curly bracket do the performance, whatever we ask from the C language. And there's another particular thing here. So we call this is the double slash, which is denoted for the comments. So it is the printf display. Actually, this line is not we call it. This is not running because this is a comment. Comment means in order to understand to us or the person or the user. After writing this kind of thing, this is like as a comment. That's a string. Printf display the string inside the quotation. So the final result of this program is this one, hello world. So it will print hello, comma, and world. So you will know better in tomorrow day school. I just go through this kind of simple program. Anyway, so this is the just we are why we telling this high level, because the user can understand. So that's we call the high level. When you are running inside that, we are calling as a low level languages, which is the assembly language and the binary code as well. Yes, there's these are some trees. So you can just get an idea about. Here you can see there's a Python and assembly language. And the Fortran is actually Fortran is the first programming language in the world. I think it came, 1950 or something like around that, 1940 or 50, which is available. The Fortran is at that time very extremely important programming language. And there are some also basic, GW basic, we call it. So like that, here is a C language, and there's a C++ again. Then it is platform to the Java, Perl. So actually, the Python also, it's a old language around the 70s, 1970s, 80s. But at that time, it was not too much popular. But nowadays, the Python and the other relevant things are very famous during this decade. Okay, so just go through these things. I just only include only for get an idea about it. Yeah, so so this is the program pane. So how I will explain this. Yeah, so so what is when you are writing a simple program? So there are some we call the paradigms. So that means the program paradigms which is relevant to some specific task. So in there, according to this, it has mentioned about four paradigms, but there are some other paradigms. But based on this your course, it is we can consider this kind of thing as well only. Other than you don't need to know about all the program paradigms. Because these are very basic paradigms. So what is the sequence of that means that you cannot interchange, or you if you given the proper sequence of the program, then it will work properly. In this example, the C language, you have to be given the proper command in a sequence way. If you need to do this one after this command, then you need to be properly write it in this way, or maybe call it some other way, because that is we call the sequence based on the sequence of the explicit command. And the other things that so those we call the imperative. And the other thing is the declarative. In the declarative, we are normally mentioned about the functional logic, and the database DBMS language. 11 is here we are using some SQL and no SQL commands. SQL means structured query language. This is relevant to the database handling. And also the object-oriented concept you will be know during this course in identify the properties of the method of some specific objects. And finally, the parallel execution. So that's mean even you write some 10-line instructions, sometimes some languages are doing the parallel communication execution. So that is actually the parallel one. So get idea about a rough idea about these things, and then later you can read yourself and ask if you are not understand. So this is actually some kind of explanation in hierarchy. So the software system is based on here. Software system is based on here. So from the software plus documentation. And remember, the complete software system is not only the software. You have to be document properly as well. Then that is we call the software system. Because you can, if you go to the some in the industry, when you are given your the customer requirement and you have solved it, and it is not enough to provide the platform that you build with that software. Not you have to be given the documentation as well. So software, and the software also is specifically is mostly you have to be the machines, not the machines, modules. Inside the modules may be some set of number of computer programs for that particular module. So that means a particular requirement. The module means actually the requirement. So for this requirement, you need this kind of 1 to n computer programs in order to success this. And there are some files. So all of these are satisfied, then you can build the software. And not only that part, the right-hand side, the documentation also mostly important when you are doing the massive project. If you go to the industry or the whatever, no need to be in industry. Even though you are doing your academic work, coursework, you need to do the documentation as well. So in the documentation, you can read the system, what is the project, and the testing, how you test, and what users it uses that particular system. So this is actually, so all the software plus documentation we call the software system. Yeah, so this is the session 3. So I will, from this session 3 and 4, I will doing by Mr. Neil. Mr. Neil is
Yes, okay, thank you.
Yeah, just or if the student can ask, then after this session, no, after these 2 sessions, 3, 4, and 4.
Yeah.
So what do you suggest? Or are there any questions from the students? Or otherwise we can ask them from after the this whole day school, no? Mr. Neil,
Yes.
you suggest?
After this
Yeah,
three
after the,
session 3 and 4.
yeah. So it will very quickly we can the student can after that after this 2 sessions 3 and 4 it is short. Is there any no in the lab one may be similar but not 100%. The one of the student asked the so lab one, do we get the same in lab sheet one in the OULMS? So I think in the OULMS it has the last year lab. Mr. Neil, it is. Yeah, so one of the assets in NRC mean NAC regional centers. Yeah, so if you do the drop period, but it's better to do the lab one because all the labs are compulsory, so you can come to the now, or you can send an email to the Mr. Neil because the Mr. Neil is handle the lab sessions. So you can because all the labs are compulsory, therefore even if you are at drop, but yeah, at drop, yeah. So you can ask whether it is possible to do the lab one before registering. Okay, so Mr. Neil, now I am handing over to you. I think you can proceed the other 2 sessions.
Okay. Thank you
And
for
then
the.
it's okay. It's okay. No worries. Then after that, if they need some questions or just some technical questions, they will ask. No, they will ask after the day school, maybe 12:30. Oh, yeah, 12:35 to 40 maybe. Yeah, I will hand over to you. Nina, you can. I think you can share now. No, the document.
Yes,
Day school link.
sharing. Yes, you remove the share, no?
Yeah, yeah. I
Okay, I
gave the
will.
course. Oh no, just maybe I can give you the full host. Okay, now I am giving you full host.
Okay, thank you. Now I will answer some questions in the chat. I will answer those things. First lab session will be conducted in Colombo Center and also Candy Center, Madhura Center, Vertical Center, and Jaffna Center also. We are trying to conduct in other centers also. If we have resource persons. And next center is,
Yeah.
sorry.
Oh no, Neela, I think it is better to answer this question after the viewer.
There are several questions, no? Yes.
Yeah,
Okay.
because they will ask regularly time to time. Then you don't have the time to do the other rest part of the day school. So better to answer that some.
Okay.
Because some of the questions is the common questions, so they you can put in the Moodle the notice on the Moodle as well. The LMS.
Yes. Okay. Session 3 has software and software engineering, product life cycle, software life cycle. What is the difference between the verification and validation, requirement elicitation, stages of software life cycle, the specific first software life cycle is waterfall. That is, there are another several software life cycles also after that evolved, and the prototyping. This is software. What is software engineering? This is the definition of software engineering in IEEE standard. The application of systematic, and this is the software engineering definition. Product life cycle. This includes how product made from the thinking point of concept to the final product. First step is concept and feasibility study. Concept is actually, if you think we want to give product to the market, profitable, we have to think about the market opportunity and an organizational need. If some company says we want this product, the producer must think about the organizational needs. Or if you are planning to make a common product, you have to think about the market. If it is profitable, you can think about to develop this product. Then the next step is requirements definitions. Can it be done? Exactly, product will do. The quality needed to be viable. We have to think what are the customers' requirements. We have to get the requirements first from the customers. There are several ways to get the requirements from the customers, like surveys and questionnaires, and most these requirement definitions are conducted before putting the keys. They are conducting surveys, and there are several experiments and the research are doing. Then the next step is high-level design. Then the high-level design is after the deciding the what product is should be developed, then the what functions should be included in the this product. They have to think what are the expected quality also. For the specific quality, what should do, and and then the lower level design. These high-level design, in the high-level design, the separate functions are defined, and then these basic functions should be divided into smaller parts. Basic components, they are functional requirements. Functional requirements are what functions should be needed in that product. Actually, these things are not only limited to the software. These things can be included in any engineering product. Engineering means that product need to be quality. the customer should be included customer satisfaction, and the customer the customer should look the better quality, better than the other same products. So if we consider a car, we have to think about pattern, the size and the model like that. Those things we have to think. And in the car, we have to think about how this body should be and then prototype. Before going to make the actual product, we have to develop a small, simple product, mostly same as the final product. Because if we make a final product, and there will be more money it will cost, and so we make a small, simple product. By making the simple product, we test the prototype. This simple product, we call it as a prototype. If the prototype is success, we will start to make the final product. And the manufacture. Then the make and market many copies of the items. Then after developing the prototype, if the prototype is success, the company should start to make then market the several products. The maintenance. After making the product, there should be a plan how to maintain those products. Most products have warranty period. Warranty periods, we are giving different types of warranties. The other is obsolescence and decomposition. Obsolescence is after several years or several months, every product should are obsolete. Means the customer may need different products. That is the people's nature. That is how actually our nature is. Every product, if we use same product, we think that we don't need it. So we have the company should give a new product. So that is the obsolescence, and the company should give a new product. This is the difference between hardware and software. With earlier product life cycle relevant to the software development also, and any other engineering product. Hardware, when we making a new hardware is also we are making different copies. But in hardware, there may be small differences between one copy to the other copy. These copies are not identical, so many may be faulty. So some manufactured copies may be fault. Some are very good. That is not like in the software. All copies are identical because same copies are in this copy, same copy are copied and sent to the market. Failures are design failures and can be transient. The old failures, if one copy have some failures, every other copies are also the same failure occurs. So most companies use patches. That means update the software by avoiding those failures. The recent software automatically updated. The most recent software like Windows, Linux, automatically the authors find the failures and they modify it and update them automatically. Software development life cycle. This is also like other software, the product life cycle. This is software life cycle. Identify a marketing opportunity for an organization. This is same as other product. The requirement capture agree on what function the system is to perform in consultation with the customer. When you are developing a software, mostly you have the software company should meet the customer company, and frequently they meet and discuss about what function actually they need, because these are customers' requirements vary time to time. It is very difficult to develop actual software, because in one organization also different people have different views about in one software. Requirement specification. Write a detailed document including functional requirement. That means functional requirements are what will the system do. So, what this system should be what functions should be included to the system. It is functional requirement. Non-functional requirements are what level of quality must it have. For example, what is the downtime? Downtime means if the system fails, in what time, what is the duration to up the system? Because it is critical in some software, it is not critical in some software. Say in we are in software company is developing software for plane. It is very critical. In milliseconds, they need to correct functions, response, software should respond very quickly. And what constraints are there on its design and security, etc. Security is also a non-functional requirement. The functional requirements are how the input, what are the processes, and how what output should we get. Those things are functional requirements. And the high-level design, how will the system meet its requirement? implementation. That is the implementation. After defining the functions and our inputs and outputs, the software system, the device should be divided into small modules, and also these modules also should be divided into smaller parts, and those things should be programmed, and this should be compiled. Compiled means we have to check these programs are correctly running. There are several errors occurs, runtime error, compile time error, like that. And then separate modules are developed, and they should also be integrated into one software system. And the user document is also in each module. The software company should write user documentation, and also system documentation. Most of the things, some times system documentations are not happening, but later the company will be cannot maintain without these documentations. And the next is testing. After compiling and integration, the system should be test whether those things, this software is correct or not. There are mainly two types of testing: black box testing and white box testing. The black box testing is just input the data and whether the outputs are correct or not, without considering what inputs, what is the what happens inside the box. White box testing is it checks each code what happens inside the code. These are white box and black box testing. And the trial. The complete system is operated in a realistic environment to validate that it meets the original requirements. Then the deployment. The deployment is give the software to the customer. And operation and maintenance. Operation and maintenance is after installing the customer company, they have to frequently check how faults occurs and how recovers them, and the obsolescence that means retire and replace. Every software also obsolete, that means it doesn't work anymore, that retired, and the need to give a new one. This is verification and validation. Verification and validation is we are building the product. In requirement analysis, we have to find out the product is check the product is right. Actually, customer need product or not. After selecting the correct product, we have to check whether the product is built in correct way. That is the validation and verification, difference between the validation and verification. Requirement elicitation. Requirement elicitation is at the beginning, before implementing before designing software, the software company should get the what the requirement of the customer, correct requirement, and the software company should be considered actually what the customer needs, and so if the existing system should be changed, they have to say that this system should be changed. This is actually the famous picture, the cartoon like that, how the customer explained it. This customer how explain it, how the project leader understood it, how the analyst designed it, how the programmer wrote it, how the business consultant described it, like those things. This is actually happening in every software development. It is very difficult to get the final product clearly. So, however, we have to improve time to time. So then later, software life cycle become agile. Agile means it is like a spiral. First phase, it develop one software, and then again it modified after some time. After some time, it modified then like that. This is waterfall life cycle, requirement analysis. After after checking the what is the requirement of the customer, software company design the software, and then there should be feedback also. Then after designing the software, the software company shows what they designed to the customer, and then construct the software. After that, constructing the software, they test the software whether it is correct or not, and the deployment is installing the software in the company. So for this, they have to install computers, network infrastructure, and installing the software, and the operation and maintenance. After installing this software, they have to look after the software company look after the company's software, whether it is working correctly or not. Prototyping is a quick construction to prototype is before implementing all the software in the software company develop a small version of this software and present to the customer, and then if the customer satisfied, prototype is modified to the actual system. This second O is finished. Do you have any questions? There are chats. Hola, Gampa Regional Center. In Gampa, I am answering these questions in the chat before starting the session 4. There is a Compass Center. In Compass Center, so we will try to conduct lab sessions. So there are no any selections in the Candy Center at LMS. Yes, we have not started yet because we couldn't find a demonstrator to the Candy Center. So if we will select a demonstrator quickly, we will appoint, and then quickly we will have a lab session in Candy Center also. When is next session? Tomorrow 10:30. Tomorrow 10:30 next session. Our next session is second day school will be tomorrow at 10:30. Programming paradigms. Programming paradigms are it says as some places as NAC. NAC centers are because when you come to do the lab sessions, there are two places, Block 12 and NAC Center. NAC Center is close to the Navala side gate, and you have to come to the Block 12 in other days because there are classes in labs. So we conduct in NAC Center. NAC Center, it is close to the Navala side gate. We are getting the recording. Yes, we will give the recordings, every recordings. We will include into the attached to the LMS for you. Please make sure you have all logged to the OU LMS. In OU LMS, yes, you all have to logged into the OU LMS. The lab session in Ratnapura. We are trying to do the Ratnapura Center, but we cannot sure it. Can I change my lab dates? No. Don't change lab dates. Is their first lab session of software development engineering now? No, coming Monday only we will give only in the Monday. I will stop answering the chat, and I will start now algorithm. The session 4 is algorithm. An algorithm is a step-by-step instruction for solving a problem to achieve a result. Algorithm is if you want to do something, you have to follow some steps. So simply, suppose we want to make a cup of tea. To make a cup of tea, you have to first boil water, and then you have to wash all the things needed to prepare teas, and then you have to add sugar, tea. If someone want to make a milk, and add milk. If someone want to add only tea, you have to make only tea, and like that. There are selections also. and these steps called algorithm. When you make software also, exact algorithm, you have to implement algorithm. When you are designing software, initially we only write algorithms. So then software company later decide according to the algorithm what programming languages should be used. There may be one or more than one programming languages also can be used and combine them. That depend on the that may be depend on the process time also, because C is faster than the Python, like that. So main processors we can make main processors C, and then some connections can be done through the Python. There's a software called radio. That is, we can make a radio like that communication device using the software. In that software, processors are C++, and the connections are Python, like that. There are so many software systems like that. The properties of an algorithm is, algorithm should be well ordered, unambiguous. Unambiguous means it should be defined clearly. We cannot say we will go. We have to write in algorithm. We have to we will go where, that should be clearly defined. Algorithm has effectively computable, and all should be computable, because otherwise we cannot include in the computer program. Produce as a result. There should be an input and output. There should in an algorithm. False and in a finite amount of time. Algorithm should not run infinitely. It should be an end point, input point and the end point. Representation of algorithm. Algorithm, we can represent algorithm in two manner: flow charts and pseudocode. Flow chart is, it is graphically, we can present flow chart graphically using algorithm. We can present algorithms graphically using flow charts. This is the process. This is the process is B equal A plus 2. It is a process. This is a sub-process. Sub-process is a collection of simple processes. This sub-process we can write sub-process, and separately we can get out from the main process, and the sub-process we can try to separate flow chart for that sub-process. The termination is, algorithm should have a start and end. We write start and end like this. This is an ellipse. This is a rectangle with two lines like this. This is only rectangle box. And arrow should be input arrow, and the output arrow should be in every symbols other than the start and end. there should be input and output arrows. In start, arrow should be from the start, end should be, arrow should be before the end. This is a decision. Earlier I told you the cup, making a cup of tea, one want to make a cup of milk. One want to make a cup of coffee. One may want to make a cup of tea. So the selection is if cup of tea, we have to make like this. If make a cup of milk, this process is like this. If make a cup of coffee, the process should be like this. Like that, there should be decision. Here, if it is a greater than 6, if it is 2, the process goes this side. If it is otherwise, if it is not greater than 6, process should be goes like this. This is input to output. Every time we have to correctly draw these symbols in a flowchart, input and output. This is pseudocode, start, end, sequence, comparison. Comparison is this decision process. Repetition is if this is in the selection, after some time it goes back. That is repetition. For while do while for do. There are several loops. This is how to make a cup of tea. Step 1, step 2, step 3, like that. We put the tea bag in a cup like that. We have to write a algorithm like this. This is actually this is a flow chart algorithm, flow chart, and symbol name. Symbol name is flow chart symbol name. We can earlier algorithm for preparing a cup of tea. This in like earlier, we cannot exactly write flowchart for the program, to prepare program. If we write a program flowchart for the program, software or computer program, it should be like this. Start, read the first number, read the second number, and this is a process. What happens to the input and what is the output? And the print or display C, stop. Start and stop. And the flow chart is like this. Start, read A, read B. What happens to the A and B? This C, A plus B, the A and B add and assign to the C. Actually here in computer program, the input data are written in right side and the answer should be right in left side. Here you can see A, B equal to C. A plus B equal to C. This is actually A, B are variable. We call a variable. In C programming, if we write A, input A, we can input any number or character, or we can write any number. Here, because of A plus B, we can input only numbers. read B. B is another number. We can input two numbers, A and B. So we in the process, it will be the computer will be add A plus B, and answer should be saved to the C. And then here output will be goes to the C, the whatever the value in C will be print in the computer output, and then end. These are the symbol name, terminator. These two are terminators. Input, process, output. This is same thing. Algorithm, flowchart, pseudocode. These are the difference between the algorithm and flowchart. This is like start, read A, read B, C equal A plus B, print C stop. Algorithm for a unit task, and algorithm maybe there are different type of algorithm. Maybe we can create several algorithms. For example, sorting. If you want to sort numbers, there are several algorithms to do the sort. These are bubble sort, insertion sort, selection sort, quick sort. These are standard sorting methods, sorting algorithm methods. But the same output will be given. These algorithms, different time durations will be. If we want to, these sorts will be depend on the size of the data. Here, introduction to the programming in C. These are this slide include who are the inventors of this C language. In C language, write instruction. These are actually compiled. We after writing the C program, we have to compile it and link and run it. This is a C program. I will explain this by actual C program. This is online C compiler called onlinegdb.com. This online C compiler. I will start programming now. In main, this is how to start C program main function. This is called main function. Start in the before writing any C program, we have to write like this, and then this open the curly bracket, and for this opening curly bracket, we have to write close in the curly bracket also, and this is the command. Okay, now we can run it. We can run it like from this pressing this button. You can see include there is an error, include stdioh or provide to provide the declaration of printf. So we have to include the we to give output. There's a separate other program. It has what should be what should do if printf command is given. The stdio.h program has this this printf. So we have to include them. This is this stdio.h is a standard file. So we write it in this less than letter stdio standard input stdio.h. So now we can now this has no error. The output will be displayed here. Suppose we want to include this one, so we can run and this will display. Every line in C programming, every line there should be a semicolon here. We will check without this semicolon. Here you can see error, expected semicolon before this close bracket. Okay, now when we this is called editor. This space called editor. Now using this we can write C programs and then run it. By running it, it convert to the intermediate code, object code, and then change it to this code to the intermediate code. Before that, it will check whatever the errors it has. Now in this is the error. So we can check the compiler will check and it gives the output what is the error, and now we can correct it and we can run it. Now it's okay. Now here this is the stdlib also another header file, a main function. This is called main function. This is opening bracket, start of block of instruction. These are comments. We call as comments. These are print a message comments. This is return function. This is usually we write So the return finish the function. Return 0. Here, stop RN, return 0. Now it's okay. Now we can write like this also. Here there's a warning sign, return 0, void pane. This is void pane. There's no output, but we give output as 0. So zero's data type. You will learn later what is the data type. This data type is different from this. If you write int, that's okay. Now there is no error. So this is the basic thing of the C program. Now next thing is now we are working with online compilers. We will conduct lab sessions through the online compilers because it is very easy. Earlier days there are no online compilers. We have to install compiler in the laptop. Then after that we can write code and compile in the computer. We should have to do that. Now there are online computers like I did now. Now variables. Variables are char, int, float, double, void. Now I will explain by running the computer online compiler using this. Now if you want something age is usually a number, so we can write age is usually integer number is no decimal places, so we can write data type as int age. We can initialize. Otherwise, if we want in C programming, we every variable, these are called variable. In every variable, we have to declare first. This is how to declare variables. This is data type. The age, the data type of the age here, data type of the age is int. We can initialize it as 0. Now we can write name. Name actually, there is no numbers. They are all no, we say gender. Gender is also male or female. We can write cha. Cha is character. Character here, we can we write cha as single character. It may single character. Age. No, we num1, yes, int num2 equals 0. Then we can write printf num1. We can assign num1 to num1 equal 2, num2 equal 4. We can assign any number to the num1 and num2. So we can declare another variable called int answer. Answer is num1 plus num2. Printf answer we can comment this by this one, these two slashes. Answer is 6. Here num1 is 2, num2 is 4. Addition we add by this command, and we give answers by like this. This is simple C program. Actually, these are we call sequence. We will you can study sequence selection iteration also in the lab sessions. Variable in the char and hold a store character in it. Int used to hold an integer, used to hold float value. Float value is that is also numbers, not like integer. Integer can be integer can include only numbers like 1, 2, 3. If you want to include 1.5, we have to declare it as a float. If you want to include bigger value, we can write double. Void is no values. Translating algorithm into C. This is flowchart. This is pseudocode. This is see what please see program. Start here. We can declare integer ABC. Print enter number. We can input by using like this: scan integer D and A. Please try these C programs and you can understand them. If you cannot understand, please come to the lab and get the answers. Practice this session, these C programs. Thank you. Now you can, if you have questions, please ask.
Excuse me, sir.
Yes.
Can sir show that code again, sir? What sir wrote?
Sorry.
Can sir show that code again, sir? That's sir type.
Wait. Is this one?
No, sir. The other one, sir wrote online.
Online. Right. This one.
Yes, sir.
Yes.
Okay.
This is I just wrote an program randomly, and we can input like this also. We can input numbers. Scan integer D is integers. Percentage D is, it should include, we can only use integers. Number, we have to write and here. We can write printf here. Enter first. We have to write semicolon at every end of line. Now write. Enter 1, say 34, enter 2, 35. What? The answer is 69. Right?
Yes, sir.
For lab 1, yes. Lab 1, you have to do on in the lab by looking lab 1 sheet. Please study the lab 1 sheet, lab 1, lab 2, lab 3, all the sheets and come. And explain why we use include STDI. STDI you don't take, we have to include because the printf command, printf and scanf command defining those header files. When we write in C programming these commands refer to those files, and in those files those files has another program to output or input how input. This is called pre-process. Before running the printf program, this files also compiled before that. We also can write another functions or programs and combine to the main program like this. We can write another program and include this main program. By including those programs, we don't have to write big lines in one code. That is the main purpose of this including. Return zero part is actually when you run it command lines, we can get output from this. So if you will understand this return, what happens in return when you study in the function. It will function in function. The output is returned to the main function. You will understand it when you study in the return functions. Can set up Visual Studio for program. Set up Visual Studio. I don't know. Visual Studio has C programming. Okay, thank you. One student has written another day school starting, so I will stop here. If you have problem, you can put in the LMS also, OU LMS. Please remember log to the OU LMS. Thank you.
Thank you, sir.
Excuse me, sir.
Yes.
Sir, I have difficulties in logging into the OUM LMS. I tried to log in. When I tried to recover the password, I still couldn't get through to it.
You are in OMIS, no? Do
Sorry,
you have you can you access the OMIS?
My OUSL.
Yes.
Yeah, I do have access to that. I also have the email address, but I can't get access to. I can't get through to the LMS account.
OU LMS. When did you register?
I was doing the foundation, and since then I've been having the same thing, but I'm just wondering if I can use the same LMS I used
No,
for the
when did
foundation.
you register? When did you come to register?
28th of March.
28th. Maybe not updated still.
Okay, sir. Okay.
But can you mail? Do you know my mail?
Sorry, sir.
Do you know my email?
Yeah, my email sorry,
No,
sir,
no,
I
my
didn't
my
get.
my email.
No, no, sir, I don't have your email address.
Can you see it?
Yes, sir.
Okay, send the problem to me. Okay.
Sir, can you just show that again?
No, I put in the chat.
Okay.
Sir,
Yes.
sir, the LMS for foundation is different from the engineering, sir.
What is the LMS in the foundation?
That's for natural science, sir.
No, no, no. What is the OULMS in
Yes, sir.
learn OS?
No, yes, sir. So we got a new link for engineering, sir. A student shared, sir.
Right. It doesn't matter. You can access OULMS.
Yes, sir.
Right. You start it in this. Only thing is name change. All others are same. Some front screen may be different because we prepared it.
Okay, sir.
Uh,
Sir, I'll send you an email with my registration number and details. Would you please look into that?
right. Okay.
Thank you very much, sir.
Is there another questions? Don't try to change lab sessions because we are facing difficulties. Okay, I will end the session.